Hi folks, welcome to Introductory Chemistry Chem 100. In this lecture, we are going to be looking at chemistry as part of our everyday life. Everything we do is chemistry. For example, the medication that we take, that is medicine, and biology, that is biology, that is all part of chemistry. If we are looking at physics and engineering, the materials that are used, like our phones, the dresses that we wear, our cars, all of those things are made of chemistry. If we get into the area of geology, for example, if you want to study rocks, you want to study the minerals that are in the rocks, you talk about the quartz, you talk about everything in rocks. The minerals, that is chemistry. If you want to talk about agriculture and environmental science, you begin to look at pesticides, you begin to look at fertilizers. All of those involve chemistry. If you look at tea, the coffee that we drink, all of those things, they involve chemistry. Because chemistry is in every area of our science, chemistry is sometimes called the central science. Now, understanding how these things work and how they behave is what is very important that we are going to look at. Now, let's look at matter. Matter is anything that has mass and occupies space. So in this picture, you look at this picture, you see clouds. So that is matter because they occupy space and they have mass. So anything that you can think of that has mass and occupies space, that is actually matter. So we are going to be looking at structure and composition here. When we talk of composition, we are talking about what something is made up of. And when we talk of structure, we talk of what something is made up of and how the components in that structure are arranged. Okay, so now looking at these pictures here, we are talking about the composition and the structure, what the things are made up of and how the components are arranged. Now, we are going to be classifying matter into two. We are going to classify matter as a mixture or a pure substance. So there are two classifications that any matter has to fall under. Either it is a pure substance or it is a mixture. So now let's look at pure substances. Examples of pure substances are elements and compounds. And for us to know what elements and compounds are, we have to start with the atom. Okay, the atom is the fundamental unit of matter. Here in this picture, we see an atom of chlorine. Okay, this is a chlorine atom right here. So we define an atom as the fundamental unit of matter. And atoms, they combine together to form an element. So an element is made up of only one type of atom. For example, we have the element chlorine, we have the element aluminum. All of those, they are made up of atoms of only one type. Okay, and when elements combine together, they then form what is known as a compound. So here we have gold. Gold is an element, and the gold has all atoms that are of one kind, the gold atoms. Now, let's look at what compounds and molecules are. We've already seen the atom, where we've said the atom is the fundamental unit of matter. We've seen the element, and we've said elements are made up of only one type of atom. Now, let's look at what are compounds and molecules. When we talk of a compound is composed of more than one type of element that is bound in fixed ratios. So there is that fixed composition when you're talking about a compound. For example, if you take the elements hydrogen and oxygen, for example, this is a water molecule. You will see that a water molecule will always have 2 atoms of hydrogen and 1 atom of oxygen. So there is that fixed composition. If you have something like hydrogen peroxide, that is H2O2, you see they also have, hydrogen peroxide also has hydrogen and oxygen, but it is in different compositions. So here, hydrogen peroxide it has a fixed composition of hydrogen and oxygen, that is a compound. Water also has a fixed composition of hydrogen and oxygen. So if you just change the composition of hydrogen here or oxygen in water, it will not more be water. So you must always remember, when we talk of substances, there is that fixed composition. Okay, now here is the water molecule that I've just explained. So molecules, on the other hand, they are groups of atoms that bind together tightly and behave as a single unit. So an example is hydrogen. Another example is chlorine. So all of these are molecules. Another example is bromine. Another example, you have water molecule. So there are groups of atoms that bind tightly together and they behave as a single unit. Now, so these are diatomic molecules. So diatomic molecules, when you hear of di, it means 2. And diatomic molecules are molecules that are made up of 2 atoms. For example, as I've already stated, we have chlorine, we have bromine, we have iodine. So you have all these diatomic molecules. So you have to remember them. You have hydrogen, you have nitrogen. So when you are writing the formula of the element, it is always with 2. So these are diatomic molecules. Now let's look at the composition of materials. We've talked of composition and structure, and when we talk of composition, we mean what the substances are made of. Here we see a copper, this tab. So that is, it is made up of copper, and everything in there is made up of copper atoms. So everything that you see here, these are copper atoms. The composition, all are copper atoms. Everything there are copper atoms. And in this other structure here, when you open the tap, water flows out. So in water has 1 oxygen atom and 2 hydrogen atoms. There is that fixed composition of the water molecule. Now let's look at mixtures. We have looked at pure substances, and we've said pure substances have fixed composition. And if you vary just one thing, it changes to something else, and it will not more be that pure substance. So there is that fixed composition. Now let's look at mixtures. Mixtures contain more than one substance, and they are not bound in a fixed ratio. For example, here, this is an alloy that is made of 2 different elements. So you mix the elements together, and they are not in fixed ratios. So mixtures don't contain fixed amount of substances that are mixed together. Now, so this is a mixture of copper and tin, and it is bronze. Now let's look at mixtures. As we have just seen, we have 2 types of mixtures, which can either be homogeneous and heterogeneous mixtures. Now, what are homogeneous mixtures? Homogeneous mixtures are mixtures that have one phase, so the components mix evenly. There is just one phase. You cannot distinguish the mixtures from each other. Now, this is an example of a homogeneous mixture here. When you mix salt with water, when you take sodium chloride, which is the normal table salt, and you dissolve it in water, it forms a homogeneous mixture because it is indistinguishable. Now, what is a heterogeneous mixture? In a heterogeneous mixture, the components do not mix evenly. And an example of a heterogeneous mixture is sand and water. Here in this picture, if you mix sand and water, you see that we have separate phases. the sun phase and the water phase. So that is a heterogeneous mixture. Now we also have other mixtures. So I'm going to show you some examples of mixtures here. We have a mixture of chocolate here in the first picture, a mixture of chocolate and dough. So it is a heterogeneous mixture where the chocolate and the dough, they don't mix, that you see the different phases. In the second picture, we see a mixture of a liquid with water. So it doesn't mix. You see the phase is different from the water phase. So we have two phases in there, and that is a heterogeneous mixture. Now, here is a cup of coffee. In a cup of coffee, that is a homogeneous mixture because the flavor components and the color components and even maybe the sugar that we add in there, everything is unique. So there is just one phase, and that is a homogeneous mixture. So that is the main difference between homogeneous and heterogeneous mixtures. Homogeneous mixtures, there is just that one phase that is indistinguishable. In a heterogeneous mixture, you have distinguishable phases. So air, for example, is a homogeneous mixture because in air we have nitrogen and oxygen, and we have some other gases that are in small proportion. So air is mostly made up of nitrogen, about 71%, about 78%, and oxygen, about 21%. So that is a homogeneous mixture. Now, how can we separate mixtures? We can separate mixtures by using a separation funnel. And when we separate mixtures, they give back the original substances that were originally mixed without any change in the composition. Okay, that is, when you separate mixtures, they give you back the original components without any change in the composition. So here, you are using a separating funnel, and the components that you had are going to separate, and you have the original components without any change in composition. Now, let's look at an overview of matter. We've said matter can be classified into two, either as pure substances or as mixtures. Now, let's look at pure substances. We said pure substances examples, we looked at elements and we looked at compounds. And we said elements are made up of only one type of atom, and compounds are made up of different types of atoms in fixed compositions. Now, we also said the other aspect of classifying matter was as mixtures. And we said mixtures, they have more than one substance. Okay, so we say a pure substance. Let me just call your attention to this. If we mix two pure substances together, we are going to obtain a mixture. For example, mixing water, which is a pure substance, and sodium chloride, which is a pure substance. So if you mix them, you are going to obtain a mixture because the composition will not be fixed. The amount of sodium chloride that you will put in water, it can be varied. So that makes it a mixture. So you can actually take two pure substances, you mix them together, and you obtain a mixture. Now we are going to look at the states of matter. So there are basically three states of matter, which are solid, liquid, and gas. And for the solid phase of matter, the solid has a definite shape, it has a definite volume. For example, if we look at the pennies here, so they have fixed shape and they have a fixed volume, they're definite. Now, what about liquids? If we are looking about liquid, the liquid state, we see that it has a definite volume but no definite shape. For example, if you take Coke and you put it into a cup, it takes the shape of that cup. So liquids will always take the shape of the container in which they find themselves, but they have a definite volume. What about gases? Gases have no fixed shape and no fixed volume, so they will always occupy anything that they find themselves in. So now we know the three states of matter: solid, liquid, and gas. Now let's see how we can transition from one state of matter to the other. And how do we call that change of state? Now, looking at this picture here, we have solid, we have a liquid, and we have a gas. So there is a way that you can move from a solid to a liquid and then to a gas. For example, if we take an aluminum bar and we heat it, an aluminum bar is solid. So if you heat it at the molecular level, macroscopically you will not see anything, but microscopically you will see that the atoms are vibrating. So if you heat it up to a temperature that is up to the melting point, the aluminum bar will melt. So it changes state from solid to liquid. And when there is that change of state from solid to liquid, we call that change of state, that transition is called melting. Now, if you continue heating the liquid that you've obtained, it is going to evaporate. And the change of state from liquid to gas is called evaporation or vaporization. Now, we've seen how you can move from solid to liquid, which is melting. You can move from liquid to gas, which is called vaporization. Now, what about the reverse processes? For example, let's look at water, boiling water. So when you are heating water, for example, in a covered pot, you see that there is a point where the water will start evaporating and it will condense on the lid of the pot. When it condenses, it falls back into the liquid state. So when it is vaporizing, when it's evaporating, that is vaporization. Now, when it gets to that gas phase, when it vaporizes, that's in the gas phase, it condenses on the lid and it falls back. So it moves from gas to liquid. So that process of moving from gas to liquid is called condensation. Now, the liquid water, for example, that we still have, we can convert liquid water into solid. So when you take water and you put it in the freezer, you are actually changing the state from liquid to solid, and that change of state is called freezing. Now, there is also another change of state that moves from solid directly to gas, and that change of state is called sublimation. So a substance changes from solid directly into a gas without passing through the liquid state, so that is called sublimation. Now let's look at how particles are arranged in substances. So the behavior of any substance is determined by the arrangement of the particles that compose that substance. For example, here we are looking at a bar of gold. This is in the solid state. In the solid state, it will have a different behavior. So these are the atoms in the solid state. And in the liquid state here, when it is heated, they take the gold, you heat it up to a very high temperature, it melts and it gets into a liquid state. At the liquid state, it has a different behavior, and at the solid state, it has a different behavior because of the composition of the substance. Now, let's look at the properties and changes. Okay, we've said all of these things that we observe are because of the changes and the properties that make up those substances. For example, here in this picture, we have a copper tube, and we are going to be looking at the physical properties. When we talk of physical properties, we are talking about those properties that can be measured without changing the identity of any substance. So the physical properties that we'll be looking at here are mass. You can measure the mass without changing the identity. You can measure the volume without changing the identity. You can measure the temperature without changing the identity. You can measure the color as well as the hardness. Okay, so all of these are physical properties. You have the melting point as well, you have the boiling point. So all of those are physical properties. So those are changes that are measured without changing the identity. Now let's look at physical change. We've looked at the physical properties. Now let's look at the physical change. Physical changes don't change the identity of a substance. So For example, we have these pennies here. They are all made of solids. These are solids. So that is, a physical change does not lead to any change in the identity of the substance. Like, for example, if we look at water, like we looked in the change of states, in the transitions. If you take ice, that is water, if you melt it into liquid water, that is a physical change because no new substance has been formed. So if you evaporate water and have gas, that is steam, there is no new substance, and that is still a physical change. So in a physical change, no new substance is formed. So physical changes are so the phase changes are physical changes. Now, this is a bar of gold here. We take this bar of gold and we melt it. We obtain liquid that is still gold. It is a physical change because we haven't formed any new substance. Now, let's continue with the properties and change. Now, let's look at chemical properties. Chemical properties cannot be measured without changing. So, they cannot be measured without changing the identity of the substance. So, with chemical properties, there is the change of the identity of the substance. And because there is that change of identity, new substances are formed. For example, here we have, in this picture, you see the glow is because the new substance has been formed that they give up that color. So chemical changes, in the chemical change, the identity of the substance changes. So the chemical change, the identity of the substance actually changes and new substances are formed. So it is also called, a chemical change is also called a chemical reaction. Now let's look at examples of chemical change. Elements combine to form compounds, and that is a chemical change. For example, if you take copper and sulfur, that is going to combine to give you copper sulfide. Okay, so a new substance is formed. As well, if you take zinc plus sulfur, that's going to give you zinc sulfide. So a new substance is formed. That is a chemical change. Now, a change that forms new compounds is a chemical change. For example, here, if we have methane, we have methane here. We're reacting methane with oxygen. This is a process that is called combustion. That is going to give you carbon dioxide and water. So this is actually a chemical change because we have new substances. Carbon dioxide is a new substance, water is a new substance. So this is a chemical change. So we've said that for chemical changes, the identity of the substance changes, and for physical changes, the identity of the substance does not change. Now let's look at change in energy. So what is energy? Energy can be defined as the ability to do work. And we have basically two types of energy that we'll be looking at this point. We'll be looking at potential energy and kinetic energy. And when we talk of potential energy, we are talking about the energy that is stored in a substance. And when we talk of kinetic energy is the energy that is due to motion of any substance. Now, let's look at heat energy. Heat energy involves kinetic energy of the particles in a substance. For example, when you heat, here in this stove, when there is that heat, when you put a pot or something, anything in the or water, for example, when you want to make coffee or tea, the water particles that absorb energy, which is kinetic energy, and the particles begin to move. So heat energy involves kinetic energy, that is energy that is due to motion. Now, the particles vibrate and that brings about the change. Now let's look at the physical and chemical changes involved in energy. So now here in this picture we see this bike rider. We are talking about potential energy at this position. When he is moving from a higher position, here his potential energy is higher, and when he is moving to a lower position, he is releasing energy. So when you move from a higher energy to a lower energy, you are releasing energy. So the potential energy is converted to kinetic energy for motion. Now when you move from a lower energy to a higher energy, you have to actually input energy. So when you push up a bike, up a mountain or up a hill, you are moving from a lower energy to a higher energy. So for plants too, there is that energy change, because for plants to manufacture their food, they need sunlight, and they combine carbon dioxide and water to make it into plant material. So the energy now is stored in that plant. Now what happens when you use that plant, when you burn it? So when you burn it, it releases that energy that has been stored. Okay, it releases the energy, and the energy is released in form of heat, and it converts the plant material that was stored back into carbon dioxide and water. So here let's look at high energy and stability. So when a substance or anything has high energy, it is not stable. It means that at that point, at the high energy, it can react. Okay, when it is stable, it is very difficult for it to react. For example, you see this rock here, the energy is high because anything that can destabilize it, you see that it is going to react. Now let's look at potential energy. Let's take the first case here, A. We are looking at a roller coaster that is dropping from the top of a hill to the bottom. So it has a potential energy at the top here, so it is unstable. So when it moves to the bottom here, it becomes more stable. Now let's look at B here. In B, we are looking at a mouse trap. So in this mouse trap, in this first part, we see that there is a coil here. There is that coil spring, and if we want to set the trap, we have to input energy and pull the coil spring backwards, and then we fix the spring such that if the mouse touches, it snaps. But once it snaps, the energy is released and the spring is stable. So here it has a high energy because we've inputted energy to pull the spring and set the trap. And once it snaps, it becomes stable. Now the third example here that we are looking at ethylene oxide. Ethylene oxide here, it is a compound that is unstable and it reacts with water. So there is this rigidity in its structure. So once you put it with water, the energy here is high. It is unstable. So once it reacts with water, it forms a product that is more stable, and it is difficult for it to react again at this point. Now let's look at what we call exothermic and endothermic change. When you hear of exothermic change, you are talking about a change that releases energy. And when you hear of an endothermic change will be a reverse. It will absorb energy. So for example, burning of wood is an exothermic change because heat is being released from the burning of wood to the surrounding. So that is an exothermic change. And when you hear of an endothermic change absorbs heat. And an example of an endothermic change is heating or cooking. When you are cooking or when you are heating anything, it actually absorbs heat. So that is an endothermic change. Now, after looking at matter and the changes that matter undergoes and the energy that is involved in all of these things, we are now going to look at what we call the scientific method. In science, the way experiments and the way everything is being done, there is order. There is a scientific method that is followed, and there are strict ways that we have to follow. So for the scientific method, what happens is that we have to make observations. So these are the states or the ways that the scientific method works. You make observations, and from the observations, you have to formulate hypotheses or ideas. And when you formulate those hypotheses or ideas, you need to test those ideas with experiments. Okay? And when those work, we will be looking at what we call hypotheses, what we call theories, what we call laws, and how they are defined. Now, let's look at a hypothesis. When you have an observation, you have to state a hypothesis. And what is a hypothesis? A hypothesis is a tentative explanation that has not been tested. So when you make an observation, you have to give a hypothesis, which is a tentative explanation that has not been tested. Now, what is a theory? A theory is an idea supported by experimental evidence. So if you have an observation and you carry out a hypothesis, you state a hypothesis, and with the hypothesis an experiment is being carried out and it is found to be true, that then becomes a theory. Now, let's look at what is called a scientific law. What is a law? A scientific law is a statement that describes an observation that are true in widely varying circumstances. So, the hypothesis is a tentative explanation that has not been tested. When that hypothesis becomes tested experimentally and it is seen to be true, that becomes a theory. Now, a scientific law is a statement that describes observations that are true in widely varying circumstances. Alright, so what is the difference between theories and laws? Laws, they tell us what happens, and theories tell us how or why those things happen. Now, let's look at scientific communication. How do scientists communicate the findings that they observe? After they have an observation, they state a hypothesis, they carry out the test, and they find out that that thing is true. How do they communicate the information that they have gotten? So scientists communicate findings through what we call scientific papers. So there are scientific papers that give us the information that the scientific method has been used to gather. So that is how the scientific method works. You must make an observation. With the observation that you've made, you state a hypothesis. With the hypothesis, you have to test, and that testing is what is experimentation. Okay, after testing, if it works, you then move to the next step. If it doesn't work, you have to state a new hypothesis. And with the new hypothesis, if it works and it is tested scientifically and proven to be true, that now becomes a theory. So that is how the scientific method works and how scientists communicate scientific findings. Now here is a picture of scientists, and I hope that in the years ahead, most of you guys are going to be great scientists, and your pictures will also be up here for doing great and mighty works in science.